But my question is, one person doing magic in front of you with the cards or with papers or with something else, okay? Another person are teaching a method to you like me, okay? I'm teaching a method to search the data or to arrange the data and all. How we two are differing?
Magic is the illusion and technique is the reason behind it.
Fine, ma.
When doing
See, I'm teaching one known technique to you because I know it and I know how to explain it. I'm explaining one technique, okay? Another person, maybe in next class, is going to do magic. How you can differentiate online students?
You are explaining the technique.
Sorry?
You are explaining the technique, but he isn't explaining the technique in magic.
Simple. That's it. Because I'm explaining a method, or I'm also doing kind of magic to find the data in the array or to sort the data in array or doing something. Okay, so I'm also doing some work, he is also doing some work, or he is trying to show something, I'm also trying to show something, right? How I mean a technician and a magician differs is, online students are able to get? So magician used to take one paper in their hand or cards. They'll do something in their hand like this, and they'll show something like this, and it will appear. So if you want to become a magician, what you have to know?
the process behind it.
Yes. So if you want to know, do a magic, then you should know about the steps, what he is doing inside his hand. So like this he used to do, right? Or maybe a different gestures, but like this he used to do, and you don't know about what he is doing inside his hand. What are that trick, what he has, we have no idea. But end of the output, he is showing something that becomes magic. Right? Yes, online students, have you clear up to this?
Yes, sir.
But when it comes to technique, I'm teaching you a technique that to find the data or to do something to process the data, I'm teaching each and every line of the process, that is called as an algorithm, right? So I'm teaching a technique with the algorithm. It will have a meaningful lines, and each and every line will lead to you to the next step or the result, right? So this is going to be the difference between magic and the technique. And once again I'm coming to magic. So how I can convert the magic into technique?
Like if you disclose the procedure.
That's it. So for some case you can disclose, for some case you can't disclose unless he teaches you, right? So that is going to be the difference. And the today's topic is about the limitations of algorithm. There is one saying is there, not all the problems can be solved either by using mathematical procedure or computational method. Have you knew about? Not all the problems can be solved, right? So there are lakhs of problem that was not solved, still it is in a research mode, like divide by zero method. What will happen if we divide a number by zero? Infinity, because we don't know exactly what will happen. So it's still in a process. We have no idea that. That's why we made it as an infinity. It's a preserved output, not a result. Okay? Yes, Pa. Yes, online students. Okay. So what I am trying to do is, we are going to discuss about the limitation and how we are going to summarize the limitation by using different method which was already existing. Okay, is my screen is visible, students? Online students?
Yes, sir, it's visible.
Okay. Already we have discussed about the math difference between magic and technique, right? So next example, we know that what is the time complexity of this algorithm, right? Can anyone tell one by one? Linear search. Linear search time complexity is how many times I used to apply the comparison? Linear search means n time, right? Binary search is half of the time. It is going to be log n. Bubble sort, I have to implement one outer loop and one inner loop. One for iteration and another one for comparison, right? So it is going to be n square. Then insertion sort, of course, n square. Merge sort, we know that what is the merge sort time complexity? N log n. And quick sort, so kind of n square will come only if we choose first element as a pivot element. When we choosing if it is in a sorted array means that would be the worst case. But for normally we used to call the time complexity of quick sort is n log n. Okay, and so these time complexities are considered as the polynomial time. So polynomial, we know that, right? So it will be like either n square, like n log n, or else multiple of n's. So there may be, we know that how we used to take the time complexity. We will take either n component or else n square. If it is there means we will take n square as a time complexity. There may be multiple expression like n square plus 1, 2, 3 like that. So we used to take the highest component which is n square, that is going to be the time complexity. It's a global way to describe. It depends on the different problem to obtain the time complexity, right? Okay. Next is about exponential time. So what is exponential time complexity is for these problems we have obtained time complexity as exponential time. That means 2 power n. I've got that time complexity as 2 power n. We know that for time complexity 2 power n and sum of subset 2 power n, n queens 2 power n. So that's how we are going to, we have found the data, right? But still the task is, if it is going to be, if an algorithm produces an exponential time complexity, then why should I use this? You know that, right? So an algorithm and method, it leads to me a worst case, the worstest case, which is the exponential case, right? The last one. So if it is if it is going to be produce a worst case time complexity, then why should I use? What is the meaning of using this time of that algorithm? So what I'm trying to do is to just think yourself as a researcher or as a discoverer. So what you are going to do is you are trying to convert these time complexities into a polynomial time. The task is from the exponential property to polynomial property. That means we have two cases. So I'm trying to convert worst case to best case. Yes. Okay, so I'm trying to convert exponential, I mean worst case to bring inside to the group of at least average case. Okay, that's what I'm trying to do. And once again I'll repeat that still for many problems it's not existing, it's not available. What we are trying to do is we are trying to make a benchmark, or we are trying to make an guidelines to the researchers or to your upcoming students. We are going to give a path or a timeline for them because they don't want to waste the time, right? They have been studying this topic from 2012 onwards. Still it was not there. Maybe my professor has studied very well before, still the case is not solved yet. Okay, so we'll discuss about this one by one. Okay, so which algorithm you will choose for searching? Binary search, why? Because linear search will give n times time complexity, but it will give you only log n, right? Okay, so how can I convert the exponential time complexity to polynomial time complexity? How can I convert? Yes, of course, I have to apply something, right? So how I am going to do? I don't know. That's the hypothesis. You don't know how to do it, right? I too don't know how to convert this. But what I'm going to do is, I'm trying to create some guidelines. The window is open. Window. Okay. So what I'm going to do is, if you are in forest now, okay, online students, please listen carefully, and this topic is going to be a bit confusing, but that kind of micro level listening is important. Okay, so if you are in a forest, you are about to discover 5 different points or 5 different locations in the forest. Okay, there may be many obstacles, okay, and sometimes you cannot reach your expected destination, I mean the expected location. What you will do? For example, let me draw. There is a forest, okay, there is a forest like this, and you are here. This is going to be the last road. You are here now, and you are about to find a location A, B. What happened? Because of this,
Next class will be online.
we'll try to make. Okay, okay. So now you are in. You are about to find out the location A, B, C. For the case, you see there is a river and there is a lake over there, and one dark forest is there, and there are lots of snakes, and wild animals are there. So, okay, you are trying to reach a destination A. So first I am trying to go to, I mean for the first attempt, I am trying to go up to the river. Okay, then I am going to come back because the river is very, I mean the river depth is high, or else I have no medium or no transportation to come across. So what I'm going to do is, I'm going to come back. I'm not going to there. So what I'm going to do is, I will save the route to reach to the river. First step, for the first attempt, I went up to river. What I'm going to do is, I will preserve this route because I don't need to try a new route to reach the river. That means there may be multiple routes. What I'm just trying to say is, I'm going to save my location. Like, I know the route to go up to river. So, but next, if I want to go to the location A, still I need some practice or some other resource to reach there. I need a boat to travel to cross the river, and after that, after crossing the river, you just imagine that there is one lake. So if I choose the lake path, then it may lead me to a wrong route, or it may lead me to some dark forest or something else. Okay, so what I'm trying to do is, again I need some resource to cross the lake. So what I'm going to do is, after my second attempt, I'll save the route up to the lake. Okay, and then I will find another resource and I will cross the lake, and then after that there may be many obstacles for that, there may be many wild animals. I must need a car or jeep to travel, so that's going to be the obstacles. Okay, so I'm creating a route, I'm preserving that route to reach a destination. Okay, so that's what I'm trying to say is, so there may be a possible solution, or there may be procedures to solve some part of the difficult problem. I mean, if you take 0 1 abstract problem, so the time complexity is 2 power n. Why the time complexity is 2 power n? We are going to try all the possibilities of given values, right? So we know that apart from that, for other cases we may have solution. So we'll discuss about that one by one. So take this algorithm. From this algorithm you can easily find that what is going to be the time complexity. Just have a look on the algorithm. There is a function n search. Yes, A is an array, n is going to be number of datas in the array, and key is going to be the element to be searched. So from this algorithm, how I can, what is going to be the time complexity? Is there any iteration over here? Is there any iteration? If is not going to be the iteration, right? It's a condition. For is going to be the iteration. Online students, simple. If n is equal to 1 means what is going to be the time complexity?
Excuse me, sir.
Yes, pa.
Still first slide is displaying, sir.
Really? Okay, we were not too far. How about now?
Now it is displaying, sir.
Okay, so just have a look on this algorithm. If n value is 1 means what is going to be the time complexity? Nice. So each operation maximum it may consume 1 unit, right? So the time complexity for this algorithm is going to be big O of 1 or theta of 1, right? So the time complexity for the given problem is going to be 1. And what about the time complexity for linear search? This is also like linear search problem, right? So for linear search n, binary search log n, but I have got one method that can produce big O of 1. That means, see here, I have no idea about the choice. It's a function. I'm going to get the return value from the choice function. And then I'm going to execute, if it is true means I'm going to execute success function. So if it is not true means I'm going to execute failure function. But I have no idea what is going to happen in these 3 functions. But I'm going to execute only a main program. It will have 3 different functions. I don't care about those functions. Okay, so what I'm suggesting is, you don't care about those functions, just execute only the main program. What are the line you have got? Okay, so for that program, what you can do is, for finding n search is going to be the destination in the forest. Okay, so I know that I have to choose, first I have to get n value. If n value is 1, or else I'm going to keep the choice. What is going to be the choice means I'm going to keep it as a task in a dark room. I'm not going to find that, because it's difficult for finding the choice operation. It may have n time. I have no idea how much time to complete that one. So what I'm going to do is, I'm going to keep a function over there. A function may lead to me a worst case that different, which is different. Okay, but I'm going to keep the function over there. So if in future someone want to do something over there using that function, then they can do. So I'm creating a guideline to complete the algorithm, right? So that's the logic behind it. So here, under the guideline, I'm going to discuss 2 important factors. First one is, usually for all the polynomial time algorithm, we are used to write, and deterministic algorithms. All the lines will have meaningful sentences and it will lead you to produce the result, right? What is non-deterministic algorithm is not all the lines, I mean, I'm going to write an algorithm, but not all the line will lead to the solution. Some lines may not lead you to the solution like what I have used in the function. Okay, so sometimes I can make a puzzle to it. For example, a puzzle result can be the input to the problem, right? So I'm having one puzzle. A puzzle result can be a number, a 10 or 12. So the 12 is going to be input for my problem. I don't care about the time what is going to take for completing the puzzle problem. Okay, so that's the logic. And second one is I'm trying to relate or also I'm trying to find the similar properties among the problem. Okay, so already Hemant have find the route to reach up to river. If Jaisurya want to reach the same destination like A, he no need to search a new route to reach river. Already Hemant know that you can give the guidelines. So if you want to go there, then I have a route up to A, you can go up to there, up to river. Then you just try to discover something else to reach the destination. This is going to be the guideline. You are going to give the guideline. You are not going to give solution to the upcoming researcher or upcoming students. You are trying to create a guideline to them, right? So preservation, that's what I told you. Preservation, which is nothing but it's not going to be the solution, or it is going to be like a route or the problem solving method that for example, there is 100% of steps required for solving one problem. Okay, so I started over here. Person 1 reached up to 10%. He preserved it. He preserved the result. And person 2, he is going to start from 10% and he will start from here to reach 20%. So if he reach 20% means person 3 will come and he will start from the 20% and he will go up to 30% or maybe expected. It may not be up to 100%, but the person maybe in future, the person N can reach up to 100% solution. So what we are doing is we are preserving the resource or the steps and we are going to consider this as a research. Okay, so I'm trying to solve, sir, but I'm not able to find, but I have solved up to this. For some problem, we don't get result, but we used to solve up to 80%, 90%, then we'll stop over there because maybe we forgot the problem formula or something else. So I've tried up to this, of course it's fine. So what the researchers are suggesting is you try to overcome the obstacles. It may lead you some other researchers, they may have no idea about what are the obstacles you have turned on, right? So that's the logic. And already we have discussed about the magic and technique. See, there may be, if it is going to be a magic, a person will do a stuff that there will be multiple techniques inside to it in the magic and you will get the result. Okay, but when it comes to technique, you will have only the line of instructions to solve or to show the result. Okay, so this is going to be done when you trying to compare with magic and technique. Okay, now the real problem coming into picture that whatever the information what we have seen up to this slide, it's not going to be a part of syllabus or questionnaire or whatever you want. So here we are going to start the exact topic what we are going to discuss is we are going to discuss about the two cases are available in non-deterministic algorithm, or for problem solving. So here what I am trying to say is, for example, P, which is nothing but polynomial, deterministic polynomial solutions. That means, yes, I have found the way and I have found the easiest way. I found a time consuming way, less time consuming way. That means, okay, this is going to be P. I found, sir. So I know some algorithm for searching a data, which is linear search and binary search. Binary search will give you less time complexity when you compare with linear search. Of course, I know linear search also, that's also comes under polynomial category only. Deterministic, this is also can solve the problem, but still it's in n case, I mean linear case, it's fine, it can produce the result. Then what about NP? NP, which is nothing but, it's not non-deterministic polynomial algorithms. So still for many problems, it's not solved it, right? It's not solved. So it is going to be like on NP. So in NP, P is a subset of NP. So try to imagine there are lots of problems are there in the world which was not solved yet, and still we have solved some problem. Of course, we have solved some problem, but not many problems are not solved yet. So that this is going to be the hypothesis. With this, we are going to start solving this issue. Okay. So still, I am repeating that we are not going to solve the problem. We are trying to give some guidelines. Okay. Now, just take for the example, for this problem, satisfiability algorithm, it's an algorithm based on the CNF formula, which is nothing but x1, listen, x1 or x2, sorry, x2 bar or x3, and x1 bar or x2 or x3. So what is means? Bar means what? In opposite value. Yes, right? Complement. Okay. So x1, x2 here, xi is going to have x1, x2, x3. So for this problem, for this given equation, I am having element x1, x2, x3, x1, x2, x3, right? So some has concatenation, I mean complement, and some was not had, right? For solving this problem, let's see, for the solving this problem, what is going to be the possible solution or possible number of options I may have for solving this problem. I need values for x1, x2, x3. It's a binary problem. We may have one, either we may have 0 or 1. Okay. So what is going to be the solution? x1, x2, x3. Either I can have 0, 0, 0, 1, 0, sorry, 0, 1, 0, 0, 1, 1, right? 1, 0, 0, 1, 0, 1, 101, 110, 111. So these are going to be the possible input for the given problem. So I can take x1 as 0, x2 as 0, x3 as 0. So this is going to be the final possible input I can give to solve the problem. I'm not going to solve the problem. So I'm trying to give, I'm going to teach you how to relate the problem. Okay, let's see. So this is going to be the available inputs. So number of inputs are 1, 2, 3, 4, 5, 6, 7, 8. So n value is 3. Number of possible input is going to be 8. Then what is going to be the time complexity? How I can get 8 from 3? That's it. 2 power 3 is going to be 8, which is nothing but 2 power n. So what I am trying to say is, for what are the problems having time complexity as 2 power n? Knapsack problem, ESP, last problem we have discussed, right? Sum of subset. No, not about. Sum of subset, n queens problem. These all are coming under the category. Just forget about this method. So if we have two method means we'll choose one, right? Which gives the simplest one. So try to say this. Knapsack also having the same property, right? So at the same time complexity. So what I'm trying to say is, see, for both the problem, it producing exponential one. This is also producing a exponential a 2 power n time complexity, and 0 knapsack also producing 2 power n time complexity. So what I'm trying to say is, what I'm trying to take the input or what I'm trying to relate is, yes, there may be a relation between these two problems. How can I overcome this? Of course, both the problems leads to worst case category only, right? So let me draw a state space tree for the given problem. If xi is equal to x1, x2, x3. So either I can take the 8 possible inputs. So how can I draw this? First one for x1, either I can take 0 or 1. Then from here I can take either 0 or 1. 0 or 1. Then from next stage, so this one for x1 and x2, x3. Either I can take 0 or 1. 0 or 1. So just turn back your notebook and find that where we have used same kind of state space tree in your problem. In which problem we have used the same kind of yes or no or cake or not. Yes. You can have a look. Say in sum of subset problem, we have used this, right? In Fibonacci also we have used. That is different. Yes or no case. Where I have used Fibonacci, I have created the space. State space tree, but each state produces the result. But here, what I'm asking is a condition that I can either choose or not for each state. For example, I'm having coin 2, 5, 1, 2, 5, 10. Okay. So if you want to give change for 21 rupees, how can I select? Either I can choose 1 or 1 not. Right? In this way I can create, right? Sum of subset problem, coin changing problem, n queens, I can choose first or second like that, right? And knapsack also. For buying a product, I can choose product 1 or product 2. Yes, I can produce next product one by one, right? So I can try to relate. So knapsack problem, sum of subset problem, coin changing problem, all having the same property called whether I can choose or not, right? Whether I can choose or not on each stages, right? So what I'm trying to say is, if I'm able to find whether I'm able to convert the satisfiability algorithm as a deterministic one, right? I can easily convert all those worst case category problem into this case, right? What I'm trying to say is, maybe cannot be possible. It's not going to be a expected one. See, I'm not telling that I'm going to solve this problem, but what I'm taking the hypothesis, So I have got the similarity between all those problems. So if I am capable to solve this particular logic, I can reduce the time. So for solving this state space tree, so it is going to be common for all those problems. So if I am able to get rid of this issue, then I can easily solve all those cases by applying the same logic. Okay, let's see. So for time complexity for the given problem, of course we know that how many number of possibilities are there here. Possible solutions are 1, 2, 3, 4, 5, 6, 7, 8. So the time complexity is going to be nothing but 2 power n, right? And how I can relate 0 1 abstract problem, state space T. So 0 1 abstract problem, choose the same logic, and coin changing problem, and sum of subset problem. So these three problems I'm going to take, because only these three we have discussed, right? So these three problems may ended up with the logic state space T. It has the options that either I can choose or I'm not going to choose, like binary yes or no, right? So that's it. So here I can choose either 0 1 or sum of subset problem. And then sir, we already explained that about P and NP. So P means polynomial and NP means non-deterministic polynomial equation, I mean algorithm, which means P, it is going to be a simple algorithm, it's solved already. NP is not solved, but it is going to be in a big number, it's not solved yet. Then what about NP hard? NP hard, which is nothing but we are going to obtain a simplified or a shortened time complexity algorithm for the worst case algorithm, right? So for example, I'm going to convert 0 1 abstract problem into, I'm going to take, for example, there is a steps that input is going to be item 1, item 2, item 3, this is going to be input. Then next what I'm going to do is, instead of writing a state space tree, I'm going to use one method, CNF. Just consider a CNF problem is solved in polynomial time. See, this is also polynomial time having, this is also having polynomial time, and this may also, the results also going to be produced the polynomial time. The only thing is in 0 1 abstract problem, to find the different possibilities, right? Finding the different possibilities is going to be the biggest task. It will consume much time than other line of codes. So what I'm trying to say is, the first line and other than that, the trying different possibilities, it will produce polynomial time only. I have no idea about the step for CNF problem. So it may produce polynomial time or it may produce worst case, I have no idea. I don't care about that. So I'm going to consider that one as a can be solved in future in polynomial time as a hypothesis. What I'm trying to convert is, so I'm going to make, so there may be a relative properties among the different problems. So I'm trying to say that yes, it may solved in this method in future. Okay, so a problem that can be converted into a NP category, that means from the worst case, from the exponential one list, from the exponential one to polynomial. So it may or may not. Okay, so I'm going to take this method or these algorithms as NP hard. That means can be found, not proved, it can be found. Okay, NP hard means, so we can convert the exponential algorithm into the polynomial algorithm, but it may be solved in future, not solved yet. Okay, and next is how I can produce the deterministic algorithm can produce polynomial time. The simple algorithm or simple method I would like to say is, listen, there is NP hard, that's what I told you, NP hard, and it may solve a problem, right? It may solve, it will have a non-deterministic algorithm and it may solve. I'm not sure about whether it can solve or not. But what I'm trying to say is the CNF problem can be solved using this method. Okay, so I have solved the CNF problem using this method, and it produces me to it produces the polynomial time complexity. I'm trying to take, okay, as I'm assuming that it produces the result and it gives efficient time complexity. So what I'm going to do is I'm going to apply this strategy into all other problem, and I can make it as out of NP hard. If the problem is solution is found, means it can be considered as a NP complete problem. Are you able to get? See, just you forgot about all the process. In the world, there are n number of problems are there. That means n number of problems are there. I mean, this is going to be NP. For some problems, we have solved the issue, and from the NP category, there are some problems in the category in the research. It may be solved in future by using this method. That is going to be considered as NP hard. Okay, the problem which we have solved is going to be considered as NP complete. NP complete, which is nothing but it has been completed by applying this method. Okay, so let me conclude is lesson. First case, from this diagram you can easily identify. First case, NP, non-deterministic polynomial algorithms. It is available in n numbers. Many problems were not solved yet, and for some problems were solved. That comes under the category P, polynomial case. And next is not able to draw. Okay, so next is NP hard by using this method. I'm trying to convert polynomial, non-deterministic to deterministic one. So I can able to describe the given problem into this category by applying this method like satisfactory problem. So I'm going to take, so this is going to be the solved one. Maybe in future it can be solved, which means it will comes under this category. This is going to be the satisfactory algorithm. So you can take any algorithm. So first you can take zero knapsack. From zero knapsack you can solve the zero knapsack state-based tree issue. Then you can apply into sum of subset or coin changing problem or whatever you want. So satisfactory problem. So this is going to be considered as NP complete. Clear? Online students? Yes? Clear up to this?
Yes, sir.
Okay. So it may be a bit confusing. The only logic is you just try to perceive like this. So there is lots of problem are not solved yet. That is going to be NP. Some problem is solved. It is going to be P. And some NP problem can be solved by using this logic, by using this method, like by using non-deterministic algorithm. And I can relate those and I can easily convert this into the next case, and that is going to be considered as NP hard. And after applying this logic I can be able to produce result, means that is going to be considered as NP complete problem. And in future, the expectation, you can call it as expectation or whatever you want, the P should be, listen, P is subset of NP, right? P is subset of NP, P is inside to NP, right? But what researchers are saying is P is not only subset of NP, P can be equal to NP. So what they are trying to say is in future there won't be no NP, non-P category. I mean NP category should not be there. It has to be for all the problems. We have to find out the solution. We have to find out the polynomial time algorithm to find out the solution, right? This is going to be the expectation or hypothesis or whatever you want. But for our syllabus, you are not going to do any research. You just forget about the research. The only thing is you have to remember all these logic to how to convert P to, I mean, exponential time complexity to polynomial time complexity. That's the logic. So whenever the question is about NP hard and NP complete, and you have to remember all these stuffs, and yeah, so this is what the final solution or expectation they may ask like this in thought-provoking questions, when P and NP will become equal or like that, right? So if all the problems were solved in NP category, then the sub NP and EP is going to be equal, right? This is going to be the answer for that kind of questions. Yes, I will explain this with another example in the next class. And with this, I'd like to say, and I'm happy to announce that we have covered all the questions. We have covered all the topics. Maybe for this NP complete and NP hard, I'll give one more example by next class. Then we are going to have one CA on Thursday, okay, for module 5. Module 4 we have taken. Module 4 we have taken only MCQs, right? So first we will have subjective type of question as a MCQ by coming Thursday. So of course we have working day up to December 25, right? So we are going to revise